Welcome to today's lesson. My name is Purity Anzelimo. We are continuing with the topic linear motion. That's the topic for today, linear motion. Before we look at the next thing, I'd like to do a recap on what we covered or what's covered in the previous lesson, that is acceleration. Just a reminder, acceleration is the rate of change in rate of change in velocity, or the change in velocity per unit time, change in velocity per unit time, and therefore acceleration is equal to final velocity minus the initial velocity all over the time taken. Again, if a body's velocity is decreasing at same time interval, if the velocity decreases with time, then we say that there is what we refer to as a deceleration. There is deceleration or retardation. There is deceleration or retardation. That is for a body moving with a velocity that is decreasing with time for equal intervals of time. For example, the velocity being from 40 meters per second and then decreasing maybe to a rest, that is 0 meters per second, then we say that there is deceleration or retardation. And therefore, we concluded by saying that a negative acceleration is therefore referred to as deceleration or the retardation. A negative acceleration, A for acceleration, is referred to as deceleration or retardation. I want us to today look at motion graphs, the motion graphs. This topic is linear motion, so we want to look at now the motion graphs. And I'll start by saying that the variation of distance, the variation of displacement, speed, velocity, and acceleration, the variation of distance, displacement, speed, velocity, and acceleration with time can be represented graphically. We can represent the variation of distance with time, the variation of displacement with time, the variation of speed with time, the variation of velocity with time, and the variation of acceleration with time. We can represent them graphically. So we have some common types of graphs that we are going to look at. Some common graphs that we need to look at, showing the variation of these quantities with time. One graph that we are going to look at is a graph we call the distance time graph. The distance time graph. Then we'll also look at displacement time graph. The displacement time graph. And also we also have the velocity time graph. So these are the graphs that we are going to look at: the distance time graph, the displacement time graph, and also the velocity time graph. Because we have seen that we can represent the variation with time graphically. So we are going to base our discussion for this lesson in the distance time graph. The distance time graph. Distance time graph. Distance time graphs. We can talk of the graphs because we are going to consider various motions. Distance time graphs. We are talking of the motion graphs. So we are going to represent various motions of bodies using the distance time graphs. Now, when you see the distance time graph, it simply refers that the distance, whenever we are plotting this graph, the distance will appear on the y-axis. So we have the distance here, the distance in the SI unit, which is meters. Then we have the time on the x-axis in seconds. So a distance time graph. The same case will apply to the others. The displacement time graph, displacement will be on the y-axis, then the time on the x-axis. Velocity on the y-axis and time on the x-axis. So I want us to start with a body, a stationary body. The distance time graph for a stationary body. A stationary body. A stationary body. When we talk of stationary, the word stationary means that it is not in motion. A body that is not moving. If a body is not moving, for example, if you place a body on a level, for example, on a table, and the body is not in motion, we say that the body is stationary. And therefore, for that body, it will cover zero distance. The distance covered will be zero. Even if the time may be changing with a certain time, maybe time changing from 1 second to 10 seconds, the distance is not changing. And therefore, we are going to have the distance time graph for that body. A distance time graph. Whenever you are plotting a graph, ensure you start with the axis. That is, we have the y-axis. Then we also have the x-axis, y and the x-axis. In our case, on the y-axis, we have the distance. And on the x-axis, we have the time. So you draw the axis. Then here, you name the axis. We have distance and the distance in meters. Then we have time, right, the SI unit of time, which is second. So for a body that is not moving, it simply means that the distance remains the same. The distance does not change, but time will keep changing. So therefore, we are going to have, let's say the distance initially is at that point, we are going to have a graph, a line that is parallel to the time axis, parallel to the time axis. So that's what we have for a body that is stationary. You can see the distance is not changing. For example, if the distance here was 2 meters, it had moved 2 meters, but now it is stationary. But the time is changing. Let's say this is 0, 1, 2, up maybe to 15 seconds. So the time is changing, whereas the distance is not changing. So this is the time, the distance time graph for a stationary body. We can see that it is a horizontal line. Is a horizontal line. That's a distance time graph for a stationary body. For a stationary body, therefore we can say that it is a straight line. A straight line, a horizontal line. Let's talk of a horizontal line. Horizontal line parallel to the time axis. Parallel to the time axis. So you can see that the distance is not changing as the time changes. Then we have number B, for a body moving at a uniform speed. We have a stationary body here. Then we have a body moving at a constant or uniform at a constant or uniform speed. A body moving at a constant or at a uniform speed. So before I explain about this body, you need to understand that whenever we have a graph, any graph of distance against time, or a distance time graph, for a distance time graph, if we have our distance here on the y-axis, distance in meters, then we have the time here in seconds, and let's say we have a graph, we have a straight line of that sort, you should always note that because we say that the speed is given by the distance covered per unit time, per the time taken. And therefore, from this graph, we can be able to see very well that if we want to calculate the gradient or the slope of this graph, if we want to calculate the slope, let's say we have the point here, we read this point and this other one, let's say here we have 0, let's say here we have T1, then on this other side for distance, let's say we have D1, then here let's say we have T2, and then here we have the distance as D2. So we are going to have at this point here, we have T1, D1, those are the coordinates. Then we have at this point, we have T2, D2. And therefore, if we want to get the slope, which we also call the gradient, we are going to have, we know that the gradient is given by change in y all over change in x. Change in y all over change in x. In our case, our y is change in distance divided by change in time, in the time axis. So we are going to have the change, we have the coordinates, so we have change in distance, so we are going to have D2 minus D1, D2 minus D1, all over change in time, whereby we have T2 minus T1. And you can see here we'll have, therefore, it's like we're having now, therefore, the distance divided by the time, the distance divided by the time. That is what is giving us the slope. And therefore, you can see the slope is equal to the speed, because this is the distance over the time taken. So we can see that for a distance time graph, the gradient or the slope gives us the speed. The gradient of that graph will give us the speed, because you can see that the gradient is change in the distance divided by the change in time, which is giving us now, this is the distance, D2 minus D1, the distance divided by the time taken from from T1 to T2. So we have divided by the time. So the slope is equal to the speed. That is for a distance time graph. So for a body moving at a uniform speed, we are going to have the graph for a body moving at a uniform speed. So this is distance time graphs. So we have the distance time graph, that is for a body moving at a constant or a uniform speed. So for a body, if the distance changes uniformly, at equal intervals of time, thereby we are going to have the graph for the body moving at a uniform speed. So we have the axis, we have the distance on the y-axis, the distance in meters, then we have the time in seconds. So if we are having the distance changing uniformly at equal intervals of time. If the distance is changing uniformly at equal intervals of time, we are therefore going to have a straight line. A straight line, and if it is starting from the starting point, if the time initially is at the 0, it will start from the origin. So we are going to have a straight line through the origin. That is for a distance changing uniformly at equal intervals of time, whereby we are saying that the body is moving at a uniform speed. So this body is moving at uniform speed, and when we want to calculate the speed of this, when you want to calculate the speed of the body, therefore you calculate the slope or the gradient, which we are going to do in the next lesson. So you calculate the slope or the gradient to get the speed of this body that is moving at a constant or uniform speed. So you can see for this, for example, if we have 0 there, let's say at this point we have 2, we have 4, we have 6, let's say we have 8, then again with the distance, let's say we have 5, then here we have 10, we have 10, and this one we have 15, then at this we can extrapolate the graph. So we are going to have at this part here, on the distance axis we have 20. So you can see that the distance is changing uniformly at equal intervals of time, meaning that this is from 0 to 5, and then the time is from 0 to 2, which is 2 seconds. So the distance there, the distance is changing from 0 to 5, and the time we have from 0 to 2. Then again with the next part, the distance is changing from 5 to 10, from 5 to 10, and then the time is changing from 2 to 4, from 2 to 4. So you can see if we continue again from 10 to 15, 10 to 15, then with the time we have 4 to 6. So you can see that the distance is changing uniformly, because this is 5, 10 minus 5, 15 minus 10 is 5. And then at equal intervals of time, whereby we have 2 here, 4 minus 2, we have 2, 6 minus 4, we have 2. So we say that this body is moving at a uniform speed. So a graph, a distance time graph, for a body moving at uniform speed is a straight line, graph, a straight line graph. So for uniform speed, a body moving at uniform or constant speed will have a straight line graph, And you can see the reason why that's happening. You can see that the distance is changing uniformly at equal intervals of time. So we've covered one at the stationary body, again a body that is moving at a constant or uniform speed. And lastly, we have a body moving at variable speed, a body moving at variable speed. So in this case, the speed is not constant, it is not uniform, but it is varying with time. The body is moving at a variable speed, meaning that maybe the speed may be increasing or it may be decreasing. So I want us to start with a case whereby the speed decreases, that is whereby the distance, therefore, distance decreases. We can start with distance increasing. Distance increases at equal intervals of time. At equal intervals of time. In this case, the distance is not changing uniformly. In this case, the distance increases at equal intervals of time. So the distance will be increasing at equal intervals of time. I want to have that graph for a body whose distance is increasing at equal intervals of time. So we are going to have the same, the two axes, the distance axis, and also we have the time axis. The distance in meters, then we have time in seconds. So this distance is increasing at equal intervals of time. So we'll have a curve whereby you can see the distance will increase. The distance will increase, this is for, this one will be decreasing. We'll have the distance increasing. We'll have it this way. So you can see at the initial point here, you can see the change in distance from this point. Let's say the time here, we can talk of 2, 4, this is 0, we have 6, 8, we have 10. Let's say the distance here is 5, 10, 15, 20, 25, and 30. So you can see initially at this point here, we use dotted lines so that it doesn't look like we have another graph. So you can see that from this point, the distance is changing from 0 to 2. Then we have the time interval. And you can see as it continues, the distance is changing from 20, at this point from 20 to 25, and the time interval here, this time interval is very small. The time interval is very small. So for this body, the distance is increasing. The distance continues to increase at equal intervals of time. So we have the curve, which is this form. That's the curve that you are going to have for a body that is moving with variable speed. So that is increasing, distance increasing at equal intervals of time. Then we also have whereby the distance decreases at equal intervals of time. At equal intervals of time, if it is decreasing at equal intervals of time, again we are going to have the graph whereby we have the distance axis. This is the distance in meters. Then we have the time in seconds. We have time here in seconds. So we have, when now it is decreasing at equal intervals of time, we have it initially this way. So we have it decreasing and then decreasing at equal intervals of time. So you can see at this point it is approaching now stationary. So we can see that the speed is decreasing. For this, there is decreasing speed. This one is increasing speed. Because we have said that for a distance time graph, the gradient or the slope will give us the speed. And you can see here the slope here is more than the slope at this point here. And therefore this body is moving at increasing speed. For this one, the slope here is very big. There is great speed, there is a very high speed here because you can see that there is a greater slope, unlike in the other part here. And therefore we say that for this body, the body is moving at a decreasing speed. the speed is decreasing with time. You can therefore talk of speed decreasing with time. Then here the speed is increasing with time, because the more the slope of this graph, the more the speed, and the lesser the slope, the lesser the speed. So here there is more speed. The speed here is high speed. Compared to this one, there is a lower speed. So we can say that this body is moving at a decreasing speed. For this one, here we can say there is a lower speed, but at this point, the slope is very high, and therefore there is high speed. So we can say therefore that the body is moving at an increasing speed. So those are the motion, that is the motion graph, that is the distance time graph, a distance time graph, whereby we've seen the distance time graph, whereby we've seen when you calculate the slope of a distance time graph, the slope or the gradient, it gives us the speed, because speed is the distance covered per unit time. And what we have on the y-axis is the distance, on the x-axis we have the time. Then we've also seen that if the body is stationary, for a stationary body, we'll have a horizontal line. If we have the distance here in meters and the time in seconds, we are going to have a horizontal line parallel to the time axis, meaning that the distance is not changing. But if the body is moving at a uniform speed, meaning that the distance is changing uniformly at equal intervals of time, for the distance in meters and the time in seconds, we are going to have a straight line graph, whereby you can, wherever you calculate the gradient, the speed will be the same. If you calculate the gradient from this point here, another person calculates from this point here, maybe another one from this one, it will be the same, meaning that the body is moving at a constant or uniform speed. Then, if the body is moving at a decreasing speed, we say therefore, this is the distance time graph, if the body is moving at a decreasing speed, it therefore means that we have it, the slope here is more than the other slope there. So this body at this point, there is more slope, so it is a higher speed than lower speed, so it is a decreasing speed. Then we also have a body moving at increasing speed, whereby we have the distance on the y-axis in meters, then against time in seconds. So we have now here the slope, then it continues and the slope becomes more. So here we have a lower slope than this. So it means that this body at this point is a lower to a higher speed. It is moving at increasing speed. So that is the motion, those are the motion graphs. That is for the distance against time. That is for a stationary body, a body moving at a uniform or constant speed, and body moving at a variable speed. That is either decreasing speed or increasing speed. So I would like to give you an exercise on describing the motion of the graphs drawn. The question is, describe the motions represented by each of the following motion graphs. Describe the motions represented by each of the following motion graphs. So you'll describe the motions for part A, B, C, D, E, and F. That is for the distance time graphs. So thank you for being attentive during the lesson. Let's meet next lesson. Thank you.